but then activated carbon as adsorbents, they are not good enough. They have some flaws. Some flaws like first, people are always looking for a better worth for the price they pay. So we are looking into bioadsorbents because they are more, we are trying to find a more cost-friendly solution to treat the water. And then the second thing is clogging. Using activated carbon might clog the water treatment tanks and stuff like that. And then finally, it will promote the formation of molds using activated carbon. So, 8 weeks ago we the reason behind this choice is because firstly, banana peels are biodegradable, so that after we use up the adsorbents, we can dispose them. It's very nature friendly. And then the next thing is it is an advantageous way of waste reuse. So we are using the fruit waste in a beneficial way. The next thing is it's cost effective. In fact, we got this sample from food store free of charge, so it's very cost effective. And then the next thing is the processes we use to process the peels are also environmentally friendly, so there are no complicated processing methods that might pollute the environment. And finally, yes, but bioadsorbents like banana peels, they are also reusable. They can be reused by cleaning or steam passing down.
Okay, for my part, it's regarding about target market. So these technologies they developed in order to improve the water treatment methods today. So our factories or companies, they often produce wastewater, waste product, water with high content of heavy metals. Like for example, it's copper. So, and for example, the heavy metals, the old auto garage copper tends to accumulate at the brakes and motor. So this one, and the factories with heavy machine like the bearings, and automobile factories doing the products of engine and brakes. So our target, besides the heavy metal, we also consider about the dyes, the factories that use a lot of dye from waste. So the banana peels can effectively remove the dyes from wastewater. So for example, the printing station, where inks are used, and excessive ink might be produced as a waste. So food factory that produce color food, like ice cream and all those sweets, DC. So this one, right? And textile factories, some artificial clothes dye may be disposed. For example, this one. And cosmetic also. Some makeup materials may contain dyes that may contaminate. So overall, we believe that our technology could be used in the industry.
Hello, I'm Rashti. So when we took the project 8 weeks back, so we consulted our lecturer to know what's the project about, and then we were informed that this is a new thing. They don't use it in the world much, so we had to do a lot of research, consulting journals, and we did this the final year project of one of our seniors, so he helped us as well. He had access to the journals, and we found out that not many countries use bioabsorbent. They prefer to use carbon, activated carbon, which is the standard material that they use for water treatment. So far what we've done, we did a lot of research to find the procedures how to process the banana peels, and we came up with very simple procedures, which are finding the bananas, cutting it up, washing it, and proceed it, dry it, and we come up with a bioabsorbent already. So then we decided, okay, how to find the most effective temperature and parameters to obtain what we want, to obtain the banana peels working as bioabsorbent at its best. So we decided to do two different batches. one oven drying and one sun drying, and both some parameters kept constant. For example, the size of the material, the pressure used, and we wanted to vary the temperature to know what's the effect of the temperature. So first thing we did, first batch we did was oven drying, which we actually process the banana peels and use our laboratories to use our oven from the laboratory to actually get our product. Next thing that we want to do is find out what's the effect with sun drying, how effective it might be. Because since we want to be more sustainable, we want to use the minimum amount of energy. So obviously oven drying costs us energy and money as well. If we can use the sun, then why not? So what we decided, the main target is firstly to produce find out the banana, of course. Get the banana, clean it with tap water, cut it into the required size, which is 5 millimeter. Sorry, this is the banana cut already. Then we grind it because we found out that okay, we can't cut too small. We decided to grind it, so we grind it into powder form. We sieved it to remove very big particles, and then we put it in the oven to dry. So this is what we came up with, our banana absorbent, and that's all.
Hello, my name is Ali. So basically, when it came to the treatment, we decided upon 3 different temperatures. Now, we have chosen different criteria as we would dry at 3 different temperatures. This is the oven, by the way. And washing the banana peels with water and then distilled water. And another option is with HCl, diluted one. This is to see which is the best strand that we can choose. So we will have enough options, 40, 50, and 60, and each one washed with either water or hydrochloric acid. They will all be tested, and the best one will be chosen, and we will, of course, write a report on each one of them, as you can see. As for the storage of the banana peels, we are going to, what I did, as you seen in the picture before, it was kept in a plastic bag. After drying it, immediately it's packed into a plastic bag, and it is sealed with a plastic sealer, airtight, as to prevent humidity from getting to it and basically contaminating and destroying the samples. Yes, I'll talk about this later. So, this is a journal by the University of Montero in Algeria. Basically, it's talking about the absorption of chemical dyes, the effectiveness of the banana peel. Now, these chemical dyes can be found, as my friend Kelvin said, in the food, paper industry, carpets, rubber, plastics, and cosmetics, and even textiles. So they made a kinetic study, which is about the energy transfer and basically the magnetism between the particles and the banana peel. And they showed that banana peels can absorb up to 19,000 milligrams per gram of banana peel of methyl blue, which is actually a very basic color dye. And this is, of course, at optimum conditions of acidic conditions, which is around 4 to 8 pH at around 20 degrees Celsius. So overall, this is just the abstract of a very long, actually, journal. And basically, it's saying that banana peels are quite effective and for the absorption of methyl blue, the basic color dye. And here is another journal by the University of Technology, Sydney in Australia. This is talking about the absorption of the metal ions, copper, copper ions. Similarly, it also works good in acidic conditions. Specifically for this one, it's around 6 pH, as you can see there. And there are other parameters that affect the absorption of the metal ion, such as, say, the particle size, that is the particle of the banana, and the pH and the dose, contact time, and agitation speed. We actually have to stimulate with some kind of agitation, mixing or whatever, and of course temperature. So from testing, we've seen that according to this journal, it can absorb up to 27 milligrams of copper ions per gram of banana peel, which is actually very great. It's about twice as much as the amount of banana peel that you have to put in. If you acidify the solution slightly with sulfuric acid, you can actually achieve a maximum of 94% efficiency in absorption, which is a very big deal. So it's ideal. So at the end of this research that we made and reading these two journals, we just found out that it's very good for absorbing dyes, and specifically the one I mentioned earlier, which is methyl blue, and copper ion metal. So this is it for our presentation.
So basically, this is our progress, and then the thing is, we have already identified our priorities. Two things. One is to reduce the heavy metal, the concentration of heavy metal in wastewater, and the second thing is the dye. And then, apart from having our targeted market, we also have came up with our procedure, and we are improving our procedure. Basically, our part, the main part is to produce the biosolvent, so we have to control stuff like the we have choices like for drying, we need to either evaporate. We are using either evaporation or oven drying, and oven drying with some preset. We have some temperature ranges, and then we also have to decide on the pH and everything like that. So this is basically what we are working on. Thank you.
Okay, I do not doubt